semiconductor device. So coming to the its characteristics are the Zener diode conducts both in forward bias as well as in reverse bias. In the yesterday's class, we have seen the PN junction diode and its characteristics. Okay. So first, let us define the Zener effect. In the last class, we have seen avalanche effect or avalanche breakdown. So similarly, in the Zener diode, it is a generally Zener diode is operated in both in forward bias as well as in reverse bias, but most of the applications uses the Zener diode in reverse bias condition. So what is the specialty when we operate the Zener diode in reverse bias means as a breakdown occurs in Zener diode. So Zener breakdown. After this Zener breakdown voltage, high currents will flow and voltage remains constant across this Zener diode. This is the special characteristic of Zener diode. So first let us define the Zener effect, how this will happen in the Zener diode. So Zener diode is made up of heavily doped PN junction diode, heavily doped PN junction. So heavily doping means we know a large amount of free electrons are present in the N region as well as in the P region. There is a heavily doped PN junction diode. So when we operate this PN junction diode in reverse bias condition, the forward characteristics of Zener diode are same as ordinary PN junction diode. Okay. So let us discuss only the reverse bias condition. So what happens means under reverse bias condition, if you increase the small voltage, the barrier width of the barrier will be increases up to certain voltage. After during this voltage, what happens means at the junction or the barrier, there exists electric field. There exists electric field due to the large amount of available free electrons. The electric field exists at this junction. Then due to this, after certain voltage, when the voltage is increased near this breakdown voltage, that is called VZ. VZ is the breakdown voltage. So at breakdown voltage, what happens means due to the high electric field, the electrons have the potential or the energy electrons which are accumulated here. Generally, electrons are flows from negative terminal of the battery to positive terminal of the battery. These electrons will acquire due to the existence of this electric field. The electric field is sufficient to energize these electrons so that the electrons will pass through the junction, so that the junction will be broken at a high electric field. So electrons will freely flows from the negative terminal through the diode, Zener diode. So it causes Zener breakdown. This is called Zener breakdown. Zener breakdown occurs at the potential called Zener breakdown voltage, VZ. If you increase the voltage beyond this VZ, the voltage across the Zener diode is remains constant. The voltage is remains constant.
Hey.
The voltage remains constant and makes the current, high amount of current will flows through the Zener diode. So what is the one application of if you draw the forward characteristics that are same as for ordinary PN junction diode, and if you see the reverse bias characteristics, this is I and this is V, the forward characteristics. If it is a silicon diode, after 0.7 volts cut in voltage, the current starts flowing through the diode. And whereas in the reverse bias, a small current in the order of microamps will flow up to this breakdown voltage. The breakdown generally occurs from 3 to 5 volts. That depends on the amount of doping. If it is heavily doped Zener diode, then at 3 volts generally the breakdown occurs and large amount of current will flow and voltage is remains 3 volts across the Zener diode. Okay. This voltage may be increased beyond the 3 volts, 5 volts, 10 volts like that. But the voltage across this Zener diode remains 3 volts, which is equal to the Zener breakdown voltage. After the breakdown, the voltage does not change and current will flow heavy current will flow through the Zener diode. This is the special characteristic that can be used that causes the Zener diode is used as a voltage regulator. Voltage regulator. As we have discussed, the uh, avalanche effect. The avalanche effect occurs in the normal PN junction diode, whereas in the we may have the doubt that whether the avalanche breakdown occurs in this Zener diode or not. Okay, true. So the avalanche effect also occurs in the Zener diode. Okay. So these two effects are independent. Both avalanche effect and Zener effect may occur in the Zener diode. So that causes some more current will flow. Avalanche breakdown means both are breakdown. Breakdown occurs means in the reverse bias also current will flow. So heavy current will flow after the breakdown. So these two processes are independent. They may occur uh, both breakdowns, avalanche and Zener can be occurred in the Zener diode. So what is the voltage at which avalanche breakdown will occur means at 5 volts roughly. At 5 volts, the avalanche breakdown occurs in the Zener diode. So this is avalanche breakdown. This is Zener breakdown. So both are independent. Both can be breakdown. Zener breakdown. Okay, so this is about the reverse characteristics of Zener diode. This Zener breakdown is represented by Vz and avalanche breakdown may represented with Va. So coming to the application of Zener diode, the Zener diode is used as a voltage regulator. And if you see the circuit of this voltage regulator, remember the battery symbols and how we are connecting the Zener diode. That is very important. This is the symbol for Zener diode. Let's see the symbol separately, draw the symbol separately. This is the symbol for Zener diode. Like ordinary PN junction diode, this is the positive terminal and this is the negative terminal. So there are many other flavors of diodes. So we need to remember the symbols. Character diode, Shockley diode. Okay. Likewise, many diodes are there. So this is the circuit for Zener, voltage regulator application. So this is the source voltage and this is the resistance that is connected in series to the source and in series to the Zener diode. To protect the Zener diode from high currents, we will place this resistor. So at Zener breakdown voltage will be the output voltage. Always this is the output voltage. After breakdown occurs, this polarity will be positive only. Okay, why? Why it is positive means the diode is connected in reverse bias manner, but at these terminals, the source voltage, some of the potential will be dropped here at RS and some potential is across the Zener diode. So this polarity is always positive and this will be connected to the our appliances. Okay, voltage regulator we know. Stabilizer is one of the example for voltage regulator. So how it function we know. Even though there are a large voltage, okay, fluctuations like from if the breakdown, Zener breakdown that is used in the stabilizer is 230 volts, then if generally it is lesser than the 230 volts, some 190 volts or 200 volts. Why? Because if the supply voltage is less than this 230 volts, 220, the device will be in the off state. So it is slightly lesser than 230, uh, around 210 volts, 200 volts like that. So if it is 190 volts, what happens? If there is a short circuit occurs at our transformer, what happens means higher than 230 volts, some 300 or 400 volts will be supplied to our household. Then many of our household appliances will be damaged. Means to which appliance will connect the stabilizers, costly equipments generally connected with stabilizer, like our ACs, refrigerators, TVs, okay, will connect with a stabilizer. So what happens means when 300 volts comes to that device, to the stabilizer, so Zener breakdown occurs at 190 volts. Then after 190 volts, if this is 300 volts also, the 190 volts only is provided to our load. The load may be AC or refrigerator or TV. Only 190 volts is supplied, remaining will be blocked out. Okay. So the device will be protected. For example, if the voltage is less than 190 volts, for example, dim, sometimes we will observe that low voltage, we will call it as low voltage, 110 volts or 100 volts, then what happens? The device completely will be in the off state. Unless the breakdown occurs in under reverse bias condition, the Zener diode acts as off switch. So device, the load is not supplied with the voltage. So it will be in the off state. Load will be in the off state. So here also the device is protected, okay, with high voltages as well as low voltage. Okay, when we connect with the voltage regulator or the stabilizer, the device will be protected by means of this Zener diode voltage regulator application. Okay, understood? So this is the voltage regulator and Zener effect. And one more thing is uh, okay, so we have seen the forward and reverse characteristics.